Tools for machining metals vary widely in composition, shape, size, and cutting angles. These variations make it possible to fit the proper tool to each machining job. As early as 1908, Norton Company established the fact that grinding wheels remove chips of metal, which are just as truly chips as those removed by a lathe or planer tool. Therefore, it is just as important to fit a grinding wheel to a job as to fit a lathe or a planer tool to its job. We're going to see a simple surface grinding operation on a block of die steel. Selecting the right wheel to fit this particular grinding job is not as difficult as it may seem. First, we must understand what the wheel marking means. The wheel that will be used is marked 32A46 H8VG. This marking may appear complicated, but once broken down into its several parts, it could not be simpler. In the first position, we find 32A, the type of abrasive, in this case, 32 alundum brand of aluminum oxide. In the second position, the number 46 indicates the size of abrasive grains, or the grit size. The next letter, H, indicates the relative hardness of the wheel, which we call grade. Following this is a number for grain spacing, or structure. Number 8 is the structure number proved best for this wheel. The next letter tells us the kind of bond used. In this case, the letter V denotes vitrified bond, and the letter G, the particular type or modification of that bond, the Norton G type of vitrified bond. For clearness, a dash separates the abrasive side of the wheel marking from the bond side. Thus, we have established the abrasive and bonding specifications of the wheel used here for dry surface grinding a block of die steel. 32 alundum abrasive of 46 grit size, H grade, number 8 structure, and vitrified bond of the Norton G type. These combinations of numbers and letters in a marking will vary for different types of wheels. In the first position will appear the symbol for one of the 9 different abrasives commonly used in Norton grinding wheels. 6 of these are of the aluminum oxide group. 2 are of silicon carbide, and 1 is diamond abrasive. The abrasive may be 32 alundum, one of the newer developments in the Norton family of aluminum oxide abrasives. It is light gray in color and particularly suited to the grinding of all kinds of tool steels. Because of the ability of this abrasive to maintain its sharpness, wheels or segments of 32 alundum abrasive grind with an exceptionally cool and fast cutting action, require a minimum amount of dressing, and hold form well. Another of the aluminum oxide abrasives is 38 alundum, which is identified by its pure white color. 38 alundum, marked 38A, is used for all kinds of light grinding, particularly on the very hard, heat-sensitive steels. It is well suited for crush truing and for other precision grinding operations where a high finish is required. 44 alundum is Norton's most recently developed abrasive. As the toughest and most durable aluminum oxide abrasive, 44 alundum is well fitted for heavy-duty snagging, such as this titanium ingot. Also for centerless, cylindrical, and internal grinding jobs, where stock removal and rate of production are of paramount importance. It is an outstanding abrasive for saw gumming and thread grinding wheels. The letter A alone in the wheel marking identifies the regular alundum brand of aluminum oxide abrasive. Also a hard and strong abrasive, regular alundum is widely used on such relatively severe jobs as portable well grinding, offhand grinding of mild steel, and for grinding crankshafts. 57 alundum abrasive has a grinding action intermediate between regular and 32 alundum abrasives. Its principal use is in cylindrical and centerless grinding wheels. Roller chain pins, which may be ground in either the soft or hard state, are a typical example of the versatility of 57 alundum abrasive. "19 alundum abrasive is a blend of regular and 38 alundum abrasives, and as such also has an intermediate grinding action. 19 alundum wheels are used for drill grinding and for internal, cylindrical, and surface grinding jobs. There are two silicon carbide abrasives. 37C means that the wheel is made of silicon carbide abrasive of the 37 crystalline type. Its color will vary from gray to black. 37 type crystalline abrasive is particularly suited to grinding cast iron, non-ferrous metals such as brass and aluminum, and non-metallics such as ceramics and plastics. 39 type crystalline abrasive differs from the 37 type chiefly with respect to its color, which is a light green, the reason some operators prefer it for grinding cemented carbide tools. Notice how the cutting edge of the dark-colored tool stands out against the light-colored wheel. The letter D stands for diamond abrasive. Specifications for diamond wheels differ from those of other wheels and are discussed in a separate film. Diamond is the hardest of all abrasives and is used for finish grinding and cutting the cemented carbides and other hard materials such as granite, quartz, glass, gemstones, marble, and ceramics. This covers the types of abrasives, so now let's look at our wheel marking again. In the second position is a number denoting the size of the grains, which tells us that the abrasive is a 46 grit size. This means that the average diameter of these grains is equal to the size of the openings in a silk screen having 46 openings per linear inch. There are 24 standard grit sizes ranging from 8, used in very coarse wheels, to 500, used in extremely fine wheels and laps. The most commonly used sizes are in this range of 24 to 80. In the third position, following the grit size, is a letter denoting the relative hardness of the wheel, which we call the grade. Grade letters run in the order of the alphabet. E, for example, is extremely soft, while Z is very hard. For the majority of precision grinding jobs, the grades required fall between the letters F and N, while grades for rough grinding and snagging range from M to Z. Grade, or hardness, is the relative strength of the bonding which holds the abrasive grains in place. In this cross-sectional view of a vitrified wheel, we see the abrasive grains, with the bond in red coating them, and also connecting them. The heavier the bond coating and the thicker the bond posts, the stronger or harder the wheel. The white areas are the pores necessary for chip clearance. Following the grade letter is a number which indicates the structure or grain spacing in the wheel. When the abrasive grains are close together relative to their size, the wheel has a denser structure, as indicated by a lower structure number, such as 4 or 5. Extra open structure or porous type wheels have high structure numbers, such as 10 or 12, and in addition are usually identified by the letter P at the end of the wheel marking. Usually you will not have to worry about structure number in wheel selection. Experience has proved that for each grit size and grade, there is a best or standard structure. The structure number is omitted from certain types of wheels which are supplied in the standard structure only. After the structure number, we find a letter that indicates the kind of bond mixed with the abrasive in making the wheel. In this case, the V stands for vitrified or ceramic bond, consisting chiefly of carefully blended clays and feldspar. Other bond symbols are R for rubber, B for resinoid, S for silicate, and E for shellac. Vitrified bonded wheels, because of their porosity, are capable of a high rate of stock removal in precision grinding operations. The rigidity of vitrified bonded wheels helps in the attainment of high precision. Practically all surface grinding operations are performed with vitrified bonded wheels. With a few exceptions, safety requirements limit the speed of vitrified bonded wheels to 6,500 surface feet per minute. To assure safe operation, this maximum safe speed in RPM is shown on the wheel blotter, wheel, or tag, and should never be exceeded. Rubber bonds provide a slight cushioning action, which is effective in obtaining a high finish together with dimensional accuracy. This ball race is a good example. Rubber bonded wheels are also widely used in wet cutting off operations, where burr and burn must be held to a minimum. And for feed wheels on centerless grinding machines. Resinoid bonded wheels, because they are strong enough to withstand shock, are widely used today on severe grinding operations, such as swing frame snagging and billet grinding. Other typical operations for which resinoid bonded wheels are well suited include roll grinding, cam grinding, and production thread grinding. Resinoid bonded wheels can be safely used at higher speeds than vitrified wheels. Thin resinoid wheels are well adapted to dry cutting off operations. For cutting off gates and risers from non-ferrous castings, this reinforced type resinoid wheel is exceptionally strong and resistant to breakage. Shellac bonded wheels are used where high finish is required, as in grinding steel mill and paper mill rolls. Here, a shellac bonded wheel is finish grinding the bevel on a circular cloth cutting knife. Silicate bond is used to a limited extent in very large wheels for grinding edge tools, such as this blade for a rotary knife. The mild-acting silicate bond releases the abrasive grains readily, keeping the wheel sharp and very cool cutting. Going back to our wheel marking, following the bond letter, there is a symbol designating the wheel manufacturer's variation of that bond. Here, it is a letter standing for G bond. It could be K for K-type of vitrified bond in a crystalline wheel, 11 type of resinoid bond, or any one of the other Norton symbols for bond variations. So in a typical grinding wheel marking, we have in the first position the type of abrasive. In the second, the grit size. The next letter indicates hardness or grade, followed by a structure number, and finally, the kind of bond with its modification. This complete marking, together with the diameter, thickness, and hole size of the wheel in that order, and the type or shape number, if other than a straight wheel, make up the wheel specifications. Now, let's examine the factors which affect the selection of the right grinding wheel. There are 6 of them. The material to be ground and its hardness, the amount of stock to be removed and the finish required, whether the grinding is done wet or dry, the wheel speed, the area of grinding contact, and the severity of the grinding operation. Let's first consider the material to be ground and its hardness, which affect the choice of abrasive, grit size, and grade. In general, aluminum abrasives are best for steels, while crystalline abrasives are better suited to grinding cast iron, non-ferrous metals, and non-metallic materials. A relatively fine grit size works best on hard and brittle materials. A coarser grit, capable of taking heavier cuts, can be used advantageously on soft and ductile materials that are readily penetrated. A drawing will illustrate this. On hard materials, the increased number of cutting points on a slightly finer grit wheel will remove stock faster than the fewer cutting points presented by a coarser wheel. Large abrasive grains cannot penetrate as deeply into the hard material without burning it. On soft ductile materials, however, the coarser grains penetrate easily and provide the necessary chip clearance to minimize wheel loading. The hardness of the material to be ground also affects choice of grade. The general rule is hard grade for easily penetrated materials and soft grade for hard materials, which naturally tend to dull the wheel faster. The softer grades release the dull grains more readily to present new sharp grains to the work. The second factor in selecting our wheel is the amount of stock to be removed and the finish required. These affect the choice of grit size and bond. As a rule, coarse grit is selected for fast cutting, and fine grit where a high finish is required. Vitrified bonded wheels are generally used for fast cutting and a commercial finish. Resinoid, rubber, and shellac bonded wheels produce the highest finish. Is the operation wet or dry? This affects the choice of grade. Softer grade wheels must be used in dry grinding to minimize the heat generated. We can use wheels about 1 grade harder in wet grinding as the coolant reduces this heat. The speed at which the grinding wheel is to be operated often dictates the type of bond. Vitrified bonded wheels should not be used at speeds over 6,500 surface feet per minute. When speeds exceed this figure, resinoid, rubber, or shellac bonded wheels should be used. But remember, the safe operating speed shown on the tag, wheel, or the blotter must never be exceeded. The area of grinding contact between the wheel and the work affects the choice of grit size and grade. A coarser grit is required when the area is relatively large, as in surface grinding, to provide adequate chip clearance between the abrasive grains. Finer grit is best for small areas. Now let's consider grade. To ensure continuous free cutting action, a softer grade wheel will provide normal breakdown of the wheel face when grinding large areas. A harder grade will stand up better under the high pressure on small areas. The severity of the grinding operation affects the choice of abrasive and grade. For example, a tough abrasive such as 44 alundum or regular alundum is required for a severe grinding operation like snagging. The mild abrasives such as 32 or 38 alundum are best for light grinding operations on hard materials, while the intermediate 57 or 19 alundum abrasives are used for grinding jobs of average severity. The severity of the grinding operation also influences the grade. Hard grades provide durable wheels for rough grinding such as snagging, while medium and softer grade wheels are generally used for precision type grinding operations. Now let's see how each of these factors influenced the selection of our wheel marked 32A46 H8VG for surface grinding die steel. First, let's examine our reason for choosing 32 alundum as the type of abrasive. According to the rules, the factors which affect the choice of abrasive are the material to be ground and its hardness, and the severity of the grinding operations. The material to be ground was steel. That meant an alundum abrasive would be best. 32 alundum was a logical choice on this precision operation because of its fast, cool cutting action when grinding this heat-sensitive steel. So, 32 alundum takes the first position in our wheel marking. Now, let's check over the factors which influence selection of grit size. First, the material to be ground was fairly hard, suggesting a medium grit size. Next, the amount of stock to be removed was moderate, and a commercial finish was required, so a medium grit size appeared correct. Another factor affecting grit size was the area of grinding contact, which in surface grinding is relatively large, so we wanted a slightly coarser grit to provide chip clearance. All of these factors add up to a medium grit size, about a 46. Next, the grade. The first factor affecting the choice of grade is the material and its hardness. This was a hard steel, so a moderately soft grade wheel was called for. Since we were grinding dry, we went one grade softer than would have been used for wet grinding. The area of grinding contact was fairly large, which suggested a relatively soft grade wheel. This operation was not severe. Stock removal was moderate, so a relatively soft grade could be used. Taking these factors into consideration, we arrive at a moderately soft grade wheel, grade H. For a 32 alundum wheel with a grit size of 46 and an H grade, the best structure was found to be number 8. Now let's check the factors that affected the choice of bond. The amount of stock to be removed was moderate, and a commercial finish was required, both conditions indicating a vitrified bond. Wheel speed was well under 6,500 surface feet per minute, so a vitrified bonded wheel could be used. Consequently, in the bond position, we add V for vitrified. We chose the Norton G type of vitrified bond to ensure cool cutting and a maximum number of pieces per dressing. We now have the complete marking. Our wheel for surface grinding this particular die steel is 32A46 H8VG. Now that we have seen how the 6 factors are used in selecting the right grinding wheel for a specific job, let's apply them to another type of grinding operation on a different type of steel, the cylindrical grinding of a spindle of medium hard steel. As you remember, the choice of abrasive is affected by 2 factors, the material to be ground and its hardness, and the severity of the operation. The material is steel, indicating an aluminum abrasive. This is a production grinding operation on mild steel with light stock removal, requiring an abrasive with intermediate grinding action, 19 aluminum. In selecting grit size, we must consider the hardness of the material, the stock to be removed, and the finish required, and the area of grinding contact. A medium hard steel requires a medium fine grit size. Final dimensions call for average stock removal, and a commercial finish is required, suggesting a medium grit size. The area of grinding contact also indicates a medium grit. These three conditions suggest a medium grit size, about 54. Four factors affect the choice of grade. The medium hardness of the steel points to a medium grade wheel. This is a wet grinding operation, permitting us to use one grade harder than for dry grinding. The area of grinding contact is average, suggesting a medium grade, and the operation is of moderate severity, again indicating a medium grade. From these factors, it appears that a medium grade, about L, would be the proper choice. The standard structure number for this wheel is 5. We have two factors to consider in choosing the bond. Medium stock removal and commercial finish suggest a vitrified bond. A tachometer check confirms that spindle speed does not exceed the safe operating speed on the wheel tag. Again, G bond is suggested for cooler cutting and more pieces per wheel dressing. So for this particular job, we come up with the wheel specification 19A54 L5VG. But bear in mind that changes within any of the 6 factors affecting wheel selection will require modification in one or more of the grinding wheel components. Selection of the right grinding wheel for a given job is not a hit or miss proposition. Simple rules make its selection a logical procedure. The choice of abrasive depends upon the type of material and its hardness, and upon the severity of the grinding operation. The grit size is determined by the hardness of the material to be ground, the amount of stock to be removed and finish required, and the area of grinding contact. In choosing the grade, we consider the hardness of the material, whether grinding will be done wet or dry, the area of grinding contact, and the severity of the grinding operation. The structure number is generally the standard proved best by experience. It is sometimes omitted. The choice of bond depends upon the amount and rate of stock removal and the finish required, and upon the maximum wheel speed. These are the 6 factors to remember. Keep these basic principles in mind, and you will know how to select the right grinding wheel. To enable you to select quickly the right wheel for a specific job, Norton Company has prepared a series of booklets with tables of wheel recommendations. These handy booklets are available without charge from your distributor.